Hello, everyone. In this video, we're going to go over polynomial functions. We're going to go over some key points of what polynomial functions are and are not. And then we're going to do some examples that goes over and uses all of this information up here. So you have that a polynomial in one variable is a function of the form, and then this right here. So you have a sub n, so that's just some constant is what it tells us right here. Then you have x to the n, and then the other important things, you got x to the n minus 1, and then it keeps going until you're just left with x, and then just a constant. So what a polynomial is that it means that it can be in any degree. So like you have a quadratic is always x squared, right? The squared is the highest degree. You've got a cubic, x cubed, that's the highest degree. A polynomial function is kind of any other function that can have any number of degrees. Okay, so if this is x to the 10th, well now this x to the n minus 1 is now x to the 9th, then you would have x to the 8th, x to the 7th, until you're just left with x and then a constant. Okay, so a polynomial includes quadratics and it includes cubics. It includes all of them, but what a polynomial says is it can be any number of degree. Okay, it's kind of a blanket for your functions here. And so as I kind of stated, like if this is x to the 10th and this is x to the 9th and you have x to the 8th to the 7th, you want that degree to be descending. And so that's why it says n minus 1, and then so on until you're left with x and a constant. And so I kind of did an example here. It really doesn't matter what you're multiplying each of these terms by, what those coefficients are, but notice I have x to the 7th, then x to the 6th, it skips x to the 5th, right? But then you have x to the 4th. So these numbers here need to be descending. And so down here, it kind of explains this probably better than I just did. It says where all of these a and sub n's are constants or coefficients. Now, here's the big thing, and you need to make sure that you box it, highlight it, something. What makes a polynomial function is that your n has to be greater than 0, so it has to be positive and it has to be an integer. An integer means that your numbers have to be whole numbers. So they must be positive and they must be wholes. Okay, we have x as a variable. Your a sub n cannot equal 0, which is your leading coefficient, and then n is the degree of the polynomial, which is going to tell us a lot about the polynomial. So we need to pay attention to whatever n is. And n right here is whatever that highest exponent is. So in this case, my n would be 7. My degree would be 7. And then the domain of a polynomial function is the set of all real numbers, which we represent in interval notation as negative infinity to infinity. As a reminder, polynomials are smooth, meaning you have no sharp corners. So your absolute values, you remember your absolute value graph is a V. So this is not a polynomial because of that sharp corner right there. And it must be continuous, meaning no gaps or holes. So if you remember doing piecewise functions, if it had a gap or a hole, those would not be considered polynomial functions. Now, as I said, we want to pay attention to that n because that degree of the polynomial tells me two things. So if I'm looking at this example here, my degree is 7. Whatever your n is tells you the maximum number of zeros or x-intercepts. So in this one, if my degree is 7, it potentially will cross that x-axis 7 times. It's the maximum amount. So it could go 5, it could go 4, it could go 3, but it will be at the most 7 x-intercepts or zeros. And then whatever your degree is, you subtract 1, and that's the maximum number of turning points. So again, in this one here, it can turn a maximum of 7 or 6 times. Okay. So let's use this information up here to answer these questions down here. Determine whether the polynomial is or determine whether the function is a polynomial function. And we do that by looking at n. If n is positive and n is a whole number, then it is a polynomial function. For those that are, we will write this in standard form, and standard form means that the exponents are descending. State the degree, which is your n, your highest exponent. We'll state the degree, the maximum number of terms, which is equivalent to n. Oh, no, sorry, the maximum number of terms, so that's n minus 1 here. And then identify the leading coefficient, so lots to do. Okay. So, is this a polynomial? Well, you look at the exponents. Are they positive? Are they whole numbers? Yes, they are. So this is yes, a polynomial. So for those that are, we have more to do. We need to write this in standard form. So standard form means that the exponents are descending, and right now they are ascending. So this x cubed will come first, then plus 4x. We need to state the degree. The degree is what we represent as n, and n is that highest number here. So my degree is 3. So therefore, the maximum amount of turns is your degree, your n minus 1. So if my degree is 3, then it has a maximum turn of 2. And then I need to identify my leading coefficient, because that's also going to tell me things later on. Your leading coefficient is the number that's in front of your first term. So in this case, because we don't see anything, that's a 1. And so my leading coefficient is 1. You want to make sure that you look at that once you have put it into standard form, not how they gave that to you. Okay, so here, is this a polynomial? Is my exponents, is my degree greater than 0 or positive in whole numbers? Yes, it is. You've got no variable here, so we don't even care about that one, but you've got x squared is positive and it is whole. So we have another poly. Okay, so let's write this in standard form. Now be kind of careful here. Not only do we need this in descending order, but I don't want this fraction here. So what here is getting divided by 5? That's both of these, right? So this is the same as 2 over 5 plus 3 over 5x squared. And now let's put this in descending order, which means I've got 3/5 x squared plus 2/5. You go x squared, we would have an x next if we had an x, and then you have your constant at the very back. Okay, my degree, we represent as n, and that's the highest exponent here. So in this case, 2. My maximum number of terms is my n minus 1. So we will have 1. And then your leading coefficient is what's out front of that leading term, in this case, 3/5. Okay, for C, when I look at these here, to determine if it's polynomial, is n greater than 0 and is it in an integer? Well, these all have positive exponents, but they are not whole numbers. So this is not a polynomial. And you can stop there. Okay, but for your note purposes, you might want to put it's not a polynomial because 2/3 and even really 1/3, but you're really just caring about that first one there. Because 2/3 is a fraction, not an integer. So because it's not a polynomial, we don't need to answer the other questions. Now, here you have to kind of be careful because when you look at this and you're trying to determine is n positive and is n an integer, well, we have positive exponents and they're all integers. They're all whole numbers. But let's do what we did here and simplify this instead of having really a rational function. Okay, let's make it to where we don't have something all divided by something. So you have to remember your exponent rules here. X squared divided by x cubed. When you divide your exponents, you subtract. So this becomes x to the negative first. And then you have basically x to the 0 here. So this becomes minus 5x to the negative 3. So now they're still integers because they're whole numbers, but they're not greater than or equal to 0. So this one is also not a polynomial. And you can stop there, but I'm going to put because n must be greater than or equal to 0.